Power steering fluid leaks can manifest in several distinct ways that every driver should recognize. Identifying these symptoms early can prevent costly repairs and dangerous steering failures. The most noticeable symptom is increased steering difficulty, especially at low speeds like parking or maneuvering in tight spaces. You'll need to apply significantly more force to turn the wheel when hydraulic assistance is reduced. Listen for distinctive whining or groaning noises when turning the wheel, particularly when the steering is held at full lock. These sounds indicate the power steering pump is struggling due to low fluid levels. Visually inspect under your vehicle for fluid puddles. Power steering fluid typically appears as red, pink, or amber-colored liquid. The location and color of these puddles can help identify the source of the leak. Regularly check your power steering fluid reservoir to ensure the level stays above the minimum mark. The reservoir is typically located near the engine and has minimum and maximum level indicators. Pay attention to unusual steering wheel vibrations or erratic steering response. These symptoms indicate inconsistent hydraulic pressure, which often results from fluid leaks affecting system performance. Secondary warning signs include dashboard warning lights in equipped vehicles, a burning smell from an overheated pump, foaming in the reservoir, or metal particles visible in the fluid. These symptoms indicate more severe system problems requiring immediate attention. Recognizing these symptoms early allows for timely repairs and prevents complete power steering system failure. If you notice any combination of these signs, have your power steering system inspected by a qualified technician immediately. Power steering fluid leaks have 5 main sources, each with different frequencies and characteristics. Understanding these common causes helps technicians diagnose problems more efficiently. Power steering pump seals account for 35% of all leaks, making them the most common failure point. These seals deteriorate over time due to heat, pressure, and contaminated fluid. Rack and pinion seals represent 30% of cases. These seals face constant exposure to road debris and steering forces, causing gradual wear and eventual failure. Pressure hoses cause 20% of leaks, while return hoses account for 10%. The remaining 5% comes from reservoir and connection failures. Proper diagnosis starts with systematic visual inspection. This fundamental step identifies obvious problems before using advanced diagnostic equipment. Visual inspection involves 4 key steps. First, check the fluid level and color in the reservoir. Dark or contaminated fluid indicates system problems that may contribute to seal failure. Next, inspect all hoses for visible cracks, bulges, or wear. Pressure hoses are particularly susceptible to heat damage and pressure spikes that cause failure. Look for fluid residue patterns around components. Fresh fluid indicates active leaks, while dried residue shows historical leak locations. Finally, examine pump and rack seals for obvious damage or fluid seepage. These high-wear areas often show early signs of impending failure. When visual inspection is insufficient, pressure testing provides definitive system assessment. This method measures actual operating pressures against manufacturer specifications. Pressure testing uses a specialized gauge connected to the high-pressure line. Normal operating pressure ranges from 1,000 to 1,500 psi under standard conditions. Testing requires specific conditions: engine at idle, steering wheel centered, and system at full operating temperature. Pressure readings outside normal range indicate pump or system problems. Advanced leak detection methods pinpoint exact leak locations when visual inspection fails. These techniques use specialized materials and equipment for precise diagnosis. The UV dye method involves adding fluorescent dye to the power steering system. After running the engine to circulate the dye, technicians use ultraviolet light to identify leak locations with high precision. The powder method uses talcum powder applied to suspected leak areas. When the system operates, escaping fluid creates visible traces on the powder, revealing exact leak points. Modern diagnostic technology includes thermal imaging cameras and electronic sensors. These advanced tools detect temperature variations and pressure changes that indicate leak locations. Thermal imaging cameras detect temperature variations caused by fluid leaks. Escaping fluid creates distinct heat patterns visible through thermal imaging, enabling precise leak location. Electronic leak sensors in newer vehicles continuously monitor fluid levels and system pressure. These sensors provide early warning of developing problems before complete system failure. Digital pressure testing equipment provides precise measurements and real-time monitoring capabilities. This technology enables comprehensive system assessment and accurate diagnosis of complex problems. Effective diagnosis combines multiple methods in a systematic approach. Starting with visual inspection and progressing to advanced techniques ensures accurate identification of leak sources and appropriate repair strategies.